Good afternoon, ladies and gentlemen, and thank you for staying with us through the afternoon. My name is Chris Berger. I lead a new team within Intel called Rackscale Customer Success Team. And the mission of the team is very simple. It's to help all of you be successful in implementing and designing in Rackscale architecture designs coming from partners such as Quanta. So in this session, we have a little bit of a three-course meal for you here. I'm going to be the appetizer, setting the stage on Rackscale design, explaining the concept, some of the key value proposition and use cases that we have seen actually resonate with a number of our end customers, both in the telecommunications sector as well as in the cloud service provider sector. Then we have Winslow actually give you a live demonstration of the technology. I would say that's probably the main course. By my estimate, you have probably seen about 104 slides now, so it's probably going to be a little bit refreshing to see actual technology in action. And then Winslow is going to, actually Ulysses is going to wrap up, be the sweetener, the dessert, and talk about some of the use cases and the innovation technology that Quanta has been developing around Rackscale design. So let's jump right into it. James this morning already spoke to some of the key tenets of Rackscale design with regards to building an infrastructure that logically and physically delineates between compute and an accelerator pool and a storage pool. Right? The advantages for doing this really focus on a couple of things. And again, I'm just going to give you like the cliff notes here. If you have more information needs, we actually have a demonstration outside as well. So the cliff notes is that by disaggregating the hardware and creating software composability, you can save money and time by just focusing on providing the best services and the optimized configuration for what you need. Very recently, actually, we were working with a very large China-based cloud service provider, and one of the key problems that they had in their data center was that they had 200 configurations of their servers in their data center. Right? So clearly, there was a big demand for agility and the ability to flexibly compose architectures. And this is really what resource pooling as well as Rackscale design provides. Because one of the key advantages is that you upgrade resources independently. Right? The CPU has a different refresh cycle than the memory, has a different refresh cycle to the NIC card, has a different refresh cycle to any kind of accelerator card. Now, but what I want to do, and we heard a lot about AI, is to put Rackscale design a little bit into context, right? And into context of Intel's vision of the evolution of the data center. This is actually quite a complicated slide, but if you kind of look at the bottom here, we have the time axis that showcases how the data center and associated technologies have evolved over time. And on this axis, we talk about the degree of automation as well as telemetry and AI that is being introduced into the data center. And over the years, we've seen Blade Center, we've seen the introduction of virtualization, right, led by companies such as VMware. We saw the age of cloud computing start to kick in. And right now, from an Intel perspective, we believe that we're kind of in the age of fog computing. And by and large, this age and this phase in the evolution is characterized by a couple of things. We have a convergence of capabilities, so software-defined, network-based, distributed data centers. There's multi-level decomposability, FAS that we heard this morning about, silicon as a service, and then also infrastructure accelerators such as GPUs or FPGAs are becoming more of kind of core characteristics of this of the data center infrastructure. But we also have visibility into the next step. And this next step is also very critical because it underlines and re-emphasizes the need for having a composable architecture. And this next step at Intel, we call it the age of ambient computing. And this is really a fully software-defined, zero-touch, autonomic infrastructure. And a lot of what Ulysses is going to talk about actually paves the way towards that vision. And in that completely software-defined world, where you have a full convergence of information technology and operations technology and full hardware and software disaggregation, this is really how rack-scale design can help you future-proof your investment. Right? Rack-scale design is the underlying capabilities and set of capabilities towards a vision towards ambient computing. So with that, Intel believes that there's a time now to rethink how the data center is built and structured. Right? So traditionally, you have the stack and rack them types of server where the server is a unit of purchase and it integrates compute, storage, and networking. With rack scale design, the disaggregation becomes very real, where you have compute, separate compute nodes, a separate storage drawer, and then accelerator drawers or slats for GPGPU or FPGA. One of the key things that we shouldn't forget is interoperability. And one of the key tenets of rack scale design has always been working with standards such as DMTF, Redfish project, as well as the Swordfish projects. At the time, we were actually about 6 to 12 months ahead of where the industry was. But over, particularly the last 6 to 12 months, Redfish has really caught up and is now becoming one of the standard mechanisms to force an interoperability approach in the industry for composable data center infrastructures. And rack scale design is very much aligned with Redfish and Swordfish and the work that's going on there. And one of the benefits of doing that is creating a broad ecosystem of vendors with rack scale design conformant systems, Quanta, of course, being one of them, all managed with a single software UI that Winslow is going to demonstrate. All right, we're going to, having talked so much about composability and disaggregation, I want to make sure that another key attributes of rack scale design does not get missed out. And that is the advanced telemetry that we actually provide as part of the software that we share with partners such as Quanta. This is a concrete use case from the largest OpenStack cluster in Central Europe. This is a communication service provider called SafeDX in the Czech Republic. And by using some of the advanced telemetry, Redfish compliant and RSD telemetry options that we provide, they were able to focus on one of their specific needs, and that was the need to reduce the PoE investment, or the PoE to reduce the power investments that they needed to make and to reduce the cooling costs. So when you're thinking about Intel rack scale design, I don't want you to just think about composability and disaggregation. The third pillar of the value proposition is advanced telemetry. And if you want to learn more about it, we have a whole case study on how they used advanced telemetry from Intel to dynamically adjust their power and thermal environments dependent on the workloads they were running in the data center. So now a very quick kind of view of the future and of rack scale design. And from an Intel perspective, the main message for the roadmap for rack scale design is very simple. If there's an Intel component that can be pooled, and it makes sense to pool it, it creates value for an end customer to pool it, we will pool it with rack scale design. Right? So we have done that with NVMe storage, both over PCIe as well as over Ethernet. We're working right now and going to release by the end of the year FPGA accelerator pooling. We're actually demonstrating some of that here at this event already over PCIe. And we have created the standard actually to allow FPGA pooling over Ethernet as well, over RDMA. And then going forward, this will extend to NIC cards, GPUs, AI-specific components, basically every major component that can be pooled that is available in the Intel product portfolio, we will start to aggregate under rack-scale design. And then on the bottom, we really talk about open manageability, right? So as the communities around Redfish and Swordfish are becoming more mature, more standardized, you will see us placing an even increased focus on making sure that we create a vibrant ecosystem of conformance solutions. All right, so I'm running almost out of time. I want to give you a few pointers. There's a lot of information on the web, on YouTube, on Intel rack-scale design. We created a little microsite that has white papers, full technical specs, videos, and customer testimonials, et cetera, on intel.com. But for me, the real proof in the pudding is pointing you into the direction where you can actually evaluate and gain firsthand real-world experience with the systems. And Quanta has been a great partner in that respect, where they have built the Rackgo R solution based on Intel rack-scale design. And I would like to ask Winslow to come up and to actually show to you. Thank you.
Okay, thank you guys for coming. I wanted to show you guys what Chris was talking about, where we created a UI to be able to actually use all the features of RSD, like composability, creating logical nodes, and actually running NVMe volumes into these nodes. So wanted to show our latest disaggregated NVMe over Fabric solution. So I just want to show you quickly how we're able to create volumes, right? So here is our UI. It looks like a very standard UI. Everything's single pane. You can access all your systems, have complete control of your systems, all the information. You can see how many systems we're running, processors, memory, storage, et cetera. So here we're in our pod center, and we already created a node here. In the interest of time, we already did create we already composed the nodes. But out on the demo floor, if you guys have time, you guys can go out there and you can actually see how to compose nodes, run the accelerators, and maybe even deploy cloud containers. All right, so here we have our pod here. You can see the systems that are inside this pod. I'll show you the health state, the power state, any single information. Show you a quick look at the topology here. I'm sorry, my internet connectivity is not as the best right now. Okay, so here you can, basically what our system does is through the pod manager, we're able to auto-learn all the topologies of the network to the downstream ports to the nodes. So here you can see we have a Quantaplex T42S2U multi-node system here. And then you can see how it's connected to, for example, our management switch, or if it's connected to maybe our 10G TOR. Clicking on this information will actually give you more information. For example, how many VLANs we've set on that. All of these can be increased or decreased basically through this UI. This helps visualize where your topology may be lacking or over-provisioned. And then in our Fabric setup, this is where we showed what systems are connected through, for example, PCIe cables. So our previously pooled NVMe devices, or even our pooled acceleration systems. And here we have our storage device, where we're going to show our NVMe over Fabric system today. So this is the current NVMe fabric system. You can see that we have two volumes attached to the initiator here. These are the devices that are attached. So why don't I go ahead and show you how directly that works. For example, I'm going to create a volume. And then we'll use a lucky number 7 and create a 7 GB NVMe storage volume. All right, so now before I actually attach that to a host where the host can actually target this NVMe volume and treat it as like a local host, let me go ahead and show you what it looks like right now. So in our inventory, we're able to look at all the nodes, what the process, what's connected here. And actually, I'm able to directly go through the serial over LAN, and we'll be able to see what exactly is attached to it right now. Okay, so if we look here, this system, this host right now actually has 2 volumes attached, a 59 gigabit volume and another 48 gigabit volume here. So let's go back to that 7 gigabyte volume that I just created right here. I'm going to attach it to this host. This is the MF7 initiator host that I named earlier. I'm going to apply it. So now looking back at our topology, we can see that this actually has been attached to this host. Here's a 7 gigabyte drive that I created. And then let's go back to the SOL and look at the NVMe devices again. Oops. A little laggy here. Okay, there we go. It's connected now. So we can see that we actually attached the 7 gigabyte volume that I just created. So basically, this is a SOL, so you're going to see that actually the OS can actually detect this drive. So let me go ahead and unattach it. Okay, so I've unattached that NVMe volume. I can go ahead and delete it or attach it to any other host. And then I can check my serial over LAN again to see what my NVMe status is right now. Okay, so you can see that actually I've unattached it. The OS only detects 2 volumes attached right now. So this is pretty exciting. If you guys have time, I invite you guys to go to our demo floor, where you can see actually we're able to do much more with this UI, right? We could attach FPGAs, we can run workloads, we can run maybe Cafe, we can deploy Kubernetes cloud containers. And if you guys really do have time, I hope that you guys will be able to go and join us there. At this time, I would like to invite Ulysses to give us a quick demonstration on Telco Workloads. Thank you.
So, hello everyone, my name is Ulysses. I'm responsible for the telco solution business, including the solutions, partners, alliances, and open community strategies. So today, I'm going to talk about how, from the technical side, how we implement the Intel RSDs into bring more down-to-earth predicts that combined with the QCT hardwares. So basically, right now you are seeing that we actually, from Winslow's, he's pulling up very good demonstrations about NVMe over Fabric. So it's mainly focusing on the hardware perspective. And however, if we look into the real telco infrastructure point of views, you really need to have a VM environment, a virtualized environment, and also you need to think about how to put those applications on top of that virtualized environment as well. So this is our team's, our Telco Solutions target, that we will really want to realize the RSDs and implement into the telco infrastructure environment. So by doing so, we have several projects together with collaborating with Intel. So in in last years, we are kick off a project called Autoscaling 1.0, and this year we also have the Autoscaling 2.0. And what we're doing is, one, at the very first step, we are trying to implement the commercials OpenStack, which is using the Red Hat OpenStack, and implement into the RSD. But before doing that, we need to understand how to implement how to use the OpenStack to collaborating with the RSD. So that is the first project that we're doing in the Autoscaling 1.0. And the second one is we're implement the one applications is the EPC applications to make it running as a workloads, and to enable that from using the RSD. So the first one, we are taking the open source, the OpenStack, and we take the components, it's called O, and we kind of implement our revise the O's and implement into the Red Hat, into the OpenStack, and to connect with the RSD. So by doing so, we can have the auto-deployment OpenStack via RSD, and also we can create bare metal environments. We can create the VM environments by using RSD. So when we combine the OpenStack into RSDs, compared to the OpenStack with no RSDs, there is a very time deployments improvements. So compare these two, you actually can save a lot of deployment times. So if the Red Hat OpenStack without the RSDs, the total deployment that we calculate is it will take 116 minutes. But if you are having the RSD implementations, you can actually decrease the times and to have the total, to take the total 36 minutes. So it can save almost 70% for the on-site deployments. And on the other hand, this year we are trying to extend our efforts in the RSD with the telemetries, because we think that the telemetry is actually the very key point for the service assurance. So in our engineering teams, we are using the collect these. Okay, we are using the collect these, and we create our own plugins to plug in to have a performance metrics interlock with the NVMe layers and also the VNF layers, so we can understand when there is a workloads up and running, what kind of the performance, what kind of the impact, what kind of the data log can be collected through the collect these, and send the data log informations to the dashboard. And when there is a threshold to reach, the dashboard will give us alert information, so that the alert information was sent to the orchestration light. The orchestration light will enable and will inform the infrastructure controller to maybe create another VMs or create another infrastructure's resource to comply with the dynamic workloads happen. So to give you a very easy chart is that because the control plane and data plane separation, so whenever there's a control plane issue the information to the collect these here, and the collect these will talk to the VNF event streaming. Then it will talk to the ONAP DCAE to call the applications and to call the inference controllers to create more data planes. And everything can be work on the RSD. So simply speaking, we are trying to put the RSDs and to implement on the virtualized environment and to insert our telemetry framework to make it up and running and to create a closed loop automations. And so because when we talk to the end customers, most of them will feedback that RSD, the concept is very good. But how about when we are trying to have the RSD going to the edge compute, going to the different location of a central office. So our teams is also trying to implement the RSD form factors into different scales based on QCT's hardwares and also based on different workloads perspective. So you can see that actually it's not just the full rack design, but actually you can separate into the basic, into the medium, and into large scales deployment for the based on the RSD form factors. And so this is my last slide. So Mark Anderson once has said the software is eating up the world. However, when we are looking into the disaggregation trend of the telco infrastructures, we know that telco they are trying to take every element on demand and as they expect. But however, if we look into a total integrations part, it's actually the average is really challenging. So QCTs, we are not only create the hardware, but we are also tend to work with lots of solution partners and to integrate on top of our infrastructures. Thank you.